We've got a lot to do, got a lot to see. We're going to be talking about probably robotics. Yeah, that's a big one, robotics. There's a lot of things moving around with robotics happening there. One of the cool ones that we're going to be talking about is Zeiss, which is, you might have known them from probably lenses like this lens right here. So they do a lot of inspection stuff, so that's pretty cool too. And then thirdly, what is it there? Hexagon. Hexagon's got some manufacturing chops, and we're going to be checking them out. So come on, let's go. We got no time to go. Good. Here we are. Check, cameraman, check out this hall. Just check it out. You see, this is check it out. This is just one hall. Just one. So we're going to be talking to Hexagon in this massive hall with all this innovation, with all this incredible solutions. Solving problems. That's what they're doing. Solving problems. We're going to catch Hexagon off guard. They're pretty skilled. Look at the people. If you're not in manufacturing, you need to be in manufacturing. You need to be something in manufacturing. All these shiny objects. Shut the front door. All right, we're here. Let's get with Hexagon. All right, Scott MacKenzie here. We're here. News and Brews. We're going to be talking about shiny things. That's right. We're on the floor right now here at MD&M West, and we're going to be talking about all this mad technology, all this incredible technology. We've got Taylor with Hexagon. Taylor, how are you?
Great. How are you doing?
Well, thank you very much. He asked me how I was doing. How about them apples? All right. What you're going to do, Taylor, you're going to take us through these shiny objects. You got some technology here. You have some technology here. You got a doggone cool looking bike over there, which we're going to end up over there, okay? So, but we're going to be running. Talk to us about this.
So this is one of our latest releases. At Hexagon, if you don't know what we do quality inspection hardware and software devices under the Manufacturing Intelligence Division. Basically, this is a really accurate 3D scanner. It's called structured light is the technology that we use. It shines a set of projected patterns onto and it has cameras that go in and scan that and are able to capture those images to complete full scan mesh data that we use for dimensional analysis. So we can compare this back to a CAD model and get a color map and do surface profiles and inspect whether it was manufactured properly. We call this semi-automated because it's paired with a turntable, so it turns and scans until it measures everything. The really cool part about this hardware, though, that we just released is that it has the first of its kind in the market to have variable zoom. So every other structured light scanner that you'll see has a fixed lens set, meaning the volume that it can see and scan in is fixed, and you have to change out a lens set if you want to change to a larger or a smaller size. This system can zoom down to about 160 millimeters and out to about 800 millimeters.
Why? I mean, why is this important?
Well, I mean, if you wanted to use one of the other systems and you had to change out those lenses, that's like a 30, 45 minute procedure to take off the old lenses, take off the projector, put the new lens set on. You had to shut down the system. You have to warm it back up. You have to recalibrate those lenses, and then you could use it. Goes for a lot faster scanning process and overall process time just to get back.
Very cool. And I would imagine it's for accuracy. Do you use this also? Oh, I'm sorry, I'm moving it.
It's totally fine. Doesn't need to be safe.
It doesn't need to be? You're good? Okay, I didn't break it. All right, talk to us about whatever this is. This is pretty cool. It's got a trigger. Yeah. It's got a lot of things going on right here.
Absolutely. So this is our Hexagon Absolute arm. So this is both a laser scanner and a touch probe, so we call this a portable CMM. But essentially, I can drag on this and I can scan an object. You can see it on the screen right there as I kind of walk this arm around. So this is a little bit faster of a process, slightly less accurate than the last system we just talked about, but really versatile. These are very portable machines.
Can I?
Absolutely. Just be careful, it's a little heavy. You gotta, yeah, there you go. Just hold the trigger down and scan. Watch, put my hand down. Put the blue line in the box here. There you go. Just hold the trigger.
Check it out. It's on the screen.
There you go. Release the trigger. All right, you got your hand in there. So yeah, same idea. We use these for quality inspection, but they're a lot more portable capability. So we can put these on tripods and other stuff. We can put them right in a CNC machine to measure parts while they're still being manufactured. And yeah, the whole point is it's quick and easy inspection with high accuracy and really fast data acquisition.
Fantastic. Okay, we've got to talk about the elephant in the room. The elephant in the room is this get out of town bike. Why is this display here, and why is it so cool?
This is Arch Motorcycles. This is one of our partners. So essentially, this is Keanu Reeves Motorcycle Company. And so we partner with them. They use actually these arms and a lot of our inspection equipment to measure these devices after they're made. These bikes are very customized. So when somebody wants to come get their bike made, you know, every part might be a little bit different, and they need to inspect those parts before they go on bikes to make sure they're made properly, right? So we partner with them. They give us cool stuff like this to come scan at the show, and you know, you know, the relationship goes back and forth like that. But yeah, they're one of our partners.
How long does it, how quickly can you have one of these things made?
That is a good question that I do not know the answer to.
Oh, man. But you're using that, once again, that scanner right over there to scan this?
To scan the bike, yeah. We're showing off the scan. Anyway, this is our XL scanner, so a little bit larger. Yep. So we can do things. The line width on that one you saw was maybe 6-7 inches wide. This one's like 600 millimeters wide, right? So you're scanning this giant area all at one time. Get a lot faster data. A little bit less accurate, but you definitely don't need the really, really tight tolerance stuff in the middle of, you know, something that big. So, yeah.
It's taking a little time to boot up. Hey, that's okay. It's not a problem.
Anyway,
Cool bike, mad technology. Taylor, you were absolutely fantastic.
Awesome.
That's a shiny object right there. That is mad technology. You come to MD&M and MD&M, you will be able to find great shiny objects like this and many, many others. So stay tuned. We're going to be right back. All right, Scott MacKenzie here, back looking for shiny objects here at MD&M. We're right on the floor right now. Zeiss is the company. Did I say that right? I did. I said Zeiss correctly. Thank goodness. And we have Trevor here. Trevor, thank you very much for saying yes and be a part of this particular conversation about shiny objects. I need to go right into it. I need to start talking about that. Whatever that is, you need to start telling us about it.
Sure. So that is our blue light 3D optical scanner. So it's using a fringe pattern. It's projecting 12 million points onto the sample as it spins around. So every time you see that sort of pattern flashed, we're gathering a bunch of data that you can see populating on the screen there. We're checking it based off of a CAD model. You can see a color map over on the right that's sort of telling you where your deviations from the nominal are. And we're able to check for tolerance down into the high single microns at the high accuracy here.
How do you know that this is out of, what are you basing this data off of? When it's nailing this particular object, it's finding discrepancies.
Yep.
What are you pinging it off of?
So it's pinged off of a nominal CAD file that's entered into there. Using these little sort of dots that are positioned on there, we can arrange the orientation of the data that we're acquiring to match that CAD so that it knows the orientation. You can see the sort of green dots, which are where the stickers are. That's aligning all of that to create sort of a best fit model so that it's able to compare the actual data that it's acquiring based off of the CAD, and sort of the variance and color deviation will give you an idea of where you're in and out of specification.
So if I take this particular tool, yep, it's nailing it, it's identifying the inconsistencies. I would get rid of it and then put another one in. What's sort of that process?
Generally speaking, yeah, you'd be rotating through your samples to check for any deviations. You'll know if you have any issues, and you'll know if they're repeat issues. If these are, say, a molded part, and you put the first sample down on the second sample, and you're starting to see similar deviations across each sample, you might know you have an issue with the mold. Then maybe you swap in the mold and actually check the mold itself, figure out where that problem lies. Was this just one sample that had an issue, or do you have a bigger issue and the mold needs to be adjusted? Or maybe it's worn out, time to swap it out for a new one.
What do we, this looks pretty good. It's truly, what's that robot in the movie? What is that? I can't remember.
I'm blanking.
Yeah.
Iron Man. I'm thinking,
No.
oh, he's got one in Iron
Yeah,
Man.
it looks like it, but
Jarvis.
there you go. We'll go with that. So what's taking place here?
So very similar process. We're still using structured blue light scanning, except now we're on a robotic arm, so we're able to look at more than one position. So on that previous one, we've got a rotating table. As the sample rotates, we're able to acquire it, but still from that one-dimensional angle. Now we can start to change the position of where it's actually acquiring the data from. So even three-dimensional parts, depending on how they're fixtured, we can get a lot more fields of view and do a much more cohesive job at creating a three-dimensional model of something that isn't necessarily a relatively flat surface like that previous part was. So now we've got an orthopedic implant, and we're able to get the bottom, the top, inside, outside, all of that information.
It's just about your QC process, what you're doing to make sure that that part meets the standards. But I would imagine just the evolution of being able to highlight the quality. I mean, you're nailing it right here.
Yeah.
There's, you might have in the past sort of let things sort of fly, but now you're not.
Yeah, and beyond that, it's a throughput thing too. A lot of times people would have been measuring something like this with a more traditional CMM, and there are still many applications that are much better suited toward that. But if you're looking for speed, you're talking minutes for full data acquisition of an entire component. So millions of data points across the entire surface versus either some quick singular points or scanning probes. So a lot more data in a much shorter amount of time is the real benefit to the 3D scan.
Trevor, you were fantastic. Thank you very much. Trevor, Zeiss, shiny object, big time. We're going to have another great conversation shortly, so stay tuned.